Okay, for those of you that are here right at the beginning, could you let me know if you can hear me? Okay, for those of you that are here right at the beginning, could you let me know if you can hear? Okay, well, this is the second installment of This Week in Subcontrabassoon. I haven't had a gig this week, which has meant that I've had a decent amount of time just to focus on the subcontrabassoon. Uh, I did have other things going on. The contrabassoon is disassembled at the moment. Trying to get that ready for the next gig, and I also have a banjo gig coming up, so I'm having to rebuild my calluses. But the main goal of this past week has been subcontrabassoon, and specifically, if you remember from the last video, my recent or my most pressing goal at the moment has been getting this the frame assembly ready. So this is the kind of the central support structure that will hold everything together, and I've made quite a bit of progress on that. So let's get right to it. The kind of least interesting thing that I worked on this week is, last time I talked to you all, I had I tried laser cutting the gaskets in silicone. I got some neoprene and tried laser cutting that, and surprisingly, it was even less successful. So I went the boring way out, and I just used an X-Acto knife with the bend frames themselves as a template, and that's what I ended up with. Works pretty well. Well, I should say they look pretty good. I still, in order to figure out if they work well, I'm going to need to get everything assembled and be able to, in order to check if they're airtight or not. So, all these gaskets are now done, or at least done for now. So to the frame itself, if you have remember the frame, the pieces, you'll remember that they had a lot of tiny holes in them, and these holes all served different functions. Some of them were going to be tapped, some of them needed to be countersunk, and others just need to be drilled out to a clearance hole. And it may not seem like a lot, but when you add it all together, it was a decent chunk of work. And that is now done. So here's a close-up of some of those holes now. These holes have been countersunk so that a screw sits flush or slightly lower than flush, so that the pieces can sit up against this gasket without so the screws don't come into contact with the gaskets. And then we also had all of these holes were tapped for these to put these studs in place. Now these studs are going to solder in eventually, but the tapping them will make it easier, make the soldering step easier. And no sense hiding it anymore. Here we have one of these frames now. Now all of these studs, they're just in here screwed in. They're not soldered yet, but all of those studs are ready to be soldered. And we have the other one. Now the smaller frame pieces are the ones that are screwed into the bins themselves, and those are also done. And I went ahead and glued the bins themselves together so that these little assemblies are essentially done. So here we have the top frame assembly. I'm going to put this gasket in place. Then sits on there like that. And then for assembly, I'm going to use these bassoon U-bend nuts. Surprisingly, I wasn't able to find anything else that would really work. I haven't decided. Jared asked if I'm going to wet sand these bins to get a very nice finish. I honestly haven't decided yet. I'm definitely going to sand the inside, the bore, some, but so this bin was sanded a little bit, you can tell. The rest of the bins haven't been, and I'll be honest, I kind of like the 3D printed texture aesthetic, so I don't know that I am going to sand the outside. But we'll see. Anyway, so back to these U-bend nuts. Surprisingly, I wasn't able to find anything else that would really work. So I ended up just ordering 19 bassoon U-bend nuts from Fox, and those will be here in a few days. So then we have the wing bend here. The boot bend, complete with the low, the tone hole for low G. So this is the tone hole that's going to be covered by the low F key. And then there's a couple of posts here for the key work will attach to. And you can see here I used heat set inserts to put these in place. And I'll eventually get those affixed more permanently. The what I'm calling the bass bend with the tone hole for low E flat over here. And finally, the bell bend. And here, since this bend is going to take a little bit of stress when it's removed and placed back, I actually added a metal rib in the middle here to take some of that, so that it's not all of the stress is on the plastic itself. Now you'll also see here that there's we'll get to this plate here is a little bit different from the others because it doesn't have a corresponding hole on these top frames. Instead, it's kind of its own smaller frame that's going to eventually connect to this joint here. Actually, this is the Newton joint, or this is a third of the Newton joint, I should say. Okay, so those are the bins. And yes, Soupman asked if they were 3D printed. All of the bins and all of these body joints have been 3D printed in ABS. So when I assembled these, instead of having to use some sort of glue, I essentially used acetone. I used acetone, which essentially chemically welds ABS together. So it's a much more secure bond than you're going to be able to get with like super glue and PLA parts. That's the big reason why I switched over to ABS. So there's one important part that's not on these frame pieces yet, and that's the sockets. The tenons are actually going to install into. Now, you might have remembered a past video where I showed off some of the pipe. That I showed off some of the pipe that I was going to be using to make these sockets. Here is another view of the pipe that I started with. Now, you might notice over here, there's just a big piece of round shaft. Acoustics is kind of cruel sometimes. If I were building a table, I could just build the table out of whatever material happens to be convenient, whether that's 1 inch pipe or 25 millimeter pipe or whatever's available. But acoustics, when you're building something that needs to work acoustically, the size is important. So most of these sockets were a size that I could make out of reasonably easy to find Schedule 40 or Schedule 80 stainless steel pipe. 3 of them, however, there was no pipe available, and my only option was to make it out of just a big solid piece of round bar. So here is one of those pieces, and here is what it became. A lot of machining, but surprisingly, it was the least expensive way I could figure to make these. So here is a view of turning down the outside of these pipes. And then we're somewhere in here. There we go. I think that's it. Yeah. And here is a view of the boring bar used to take down the outside. Or sorry, the inside. Bringing those both together so that the end result is a socket with a 1 1/4 millimeter wall thickness. That's the exact size necessary for these sockets. So now, if we go back to our frames, we can also use those aluminum blocks that I talked about last time to put those in place. So here is one of my sockets. Get that block in place, and that's going to have that centered on that hole. Same thing over here. Then we have, what's that? Some of these blocks I need to sand a little more. I wouldn't want these to get stuck and then have to bang on everything to get it unstuck. Moses asked if these are the final outside widths of the pipes. Yes, they are. Everything here is essentially ready to solder together. The only bit of machining that I have left is I'm going to go in and I'm going to drill some holes for alignment pins so that when these pieces are in place, the alignment pin will let you know exactly what angle these joints need to be assembled at. Alright. And same thing over here for the bottom frame. And those are the very... Sorry about that. Anyway, you all get the idea. The bottom frame. So yeah, those two, the two big frame pieces are pretty much ready to solder. And then there's also this bend here, which has its own socket. It's going to be soldered to this plate. Of course, I'll have to disassemble this unless I want just a molten heap of ABS. And that, once again, because I know it makes Brett go woo, that's how the Newton joint is going to be assembled on the bell. Here, and let me show you real quick how that's going to go together. Okay, good. So let's get this gasket on. Okay. Then, this is going to assemble with these thumb screws. Yes, Evan, this is going to be a very big oboe. Big enough that it's kind of hard to get into frame. Yeah, so the idea is that with these thumb screws here, you will be able to remove this bell assembly without having to disassemble the entire instrument. Now it's a little bit snug. This distance here, you can hear how the how it's kind of scraping on the studs a little bit there. So what I'll need to end up doing is go through and file this hole just a little bit, just for a little more clearance. I was actually pretty impressed with how well that lined up together, considering this bend doesn't have a metal plate on the bottom to control the size. The only thing controlling the width of this is how much I sanded these joints together before assembling them. So the fact that it only needs a very light filing to work, I'm pretty relieved about that. Okay, let's real quick, just going to put the rest of these on so you all can see this entire top frame put together. So there's that. And then that. And then, of course, we have all these sockets that are going on underneath them. Yeah, Matthew says that it took him 8 hours to make a toy train in CAD. Yes, the Subcontrabassoon is definitely the most complex CAD project I have by probably 2 orders of magnitude, considering most of my CAD projects were little standoffs for my old job. Yes, there's a lot of parts, and I am very excited. There's been a few hiccups and a few things that could be a little bit better, but I'm very excited with how well everything is lining up. Okay. So now the bottom frame. Now one of the frustrating things about the bottom frame is that the top frame is comfortably asymmetric, but the bottom frame is very symmetric, so it's easy to put these gaskets on the wrong way and the bins on the wrong way. I mean, the bins won't fit the wrong way, but they'll just almost fit. Case in point. Okay, and there's the bottom bend. And here is where the end pin assembly is going to go. And speaking of that, I also got the end pin completely finished. I made this, and these are actually 2 pieces. This piece of 12 millimeter trapezoidal lead screw, mainly used for 3D printers, but it happened to work perfect for my purposes. And then a piece of just stainless steel shaft. Since I live in the United States, getting 12 millimeter stainless shaft is essentially impossible, so I just turned down some 1/2 inch. Actually, I think it was 5/8, and because for some reason we didn't have any 1/2 inch at the shop. Yeah. So I do think I have a video of the 2 pieces separate, so you can kind of get an idea. Well, you're not gonna. Unfortunately, I didn't take a picture of the 2 pieces, but here's the end pin. And that's going to go on the end pin assembly, or thread into the end pin assembly. And that's going to go in there like that. Now, a very common question I get is, why is the end pin at an angle? And that's simply to put the base, where it rests on the ground, as close to the center of underneath the center of gravity of the instrument as possible, to get as much weight off of your hands as possible, or realistically, as much weight off of the stand that's holding the instrument up. Yeah, Brett said that he's held the mock-up and it's not as big as you'd think, and I know we're both biased here, but it's really not. In fact, it may not look like it, but I'm pretty close to getting the whole thing, or being able to have an instrument that looks like the instrument. It's still going to be missing the tube, the bocal, and 2 of the joints. But I'm not too far away from being able to show that off. Jared asks, are you supposed to take the pin out after use or just screw it in all the way? That kind of depends on how the case is designed, and the case is like the least of my worries right now. The reason I made it in 2 pieces like this is because I wanted a solid piece of shaft, so it would only thread in so far. Because of the angle that it's at, if it goes in any further than this, it would ram into the instrument itself. So I didn't want it to be able to do that. Also, if it could go in an arbitrarily far distance, it would be possible, or it would be easier for it to rest on the bend as opposed to the end pin. And I don't want to, the whole reason for this design was to get the weight off of the bends, which is why this end pin is directly connected to the frame rather than the bends themselves. So, with all that put together, we're pretty close to soldering the whole frame together. The one thing I may end up doing is this end pin receiver here, I might remake it. And it's not because it's a little bit lumpy, this curve here. I mean, honestly, considering I don't have a CNC lathe and I was doing that freehand, just with the long feed in one hand and the cross feed in the other hand, I think a little bit lumpy is just fine. The problem is, once again, I didn't have a close fit for a 12 millimeter reamer, which meant that this, if I unthread this so that it's not on the threads anymore, it's just the shaft, like this end, the thin end isn't threaded. You can see it wobbles quite a bit. And what that means is if you try to tighten it down to lock it in place, it actually takes a pretty good bit of force to do that, because you're having to crunch that stainless down quite a bit. And I don't think I'd be able to lock that in place with just a thumb screw. I think I'd have to use an Allen wrench or something. So I may end up remaking this end pin receiver real quick before I solder everything together, because once this is in place, it's there for good. Okay. One last thing. If we open up, yeah. So if we go back to the Design Explorer, there's a piece that I haven't talked a lot about, and this is this support column here. Now, in this view, I have it as just one long solid piece. The plan was originally aluminum. And I've rethought that just a little bit. So the new design looks like this. So instead of one solid piece, so the downsides to having one solid piece are that these 2 plates on the end would have to be welded together perfectly in line with each other. Otherwise, you would be putting a twist on the instrument when you tighten down the column. And it would also mean that when you weld together these plates to the column, if it warps, if the plates warp, well, okay, if you're welding it, the plates will warp. if the plates warp in a particularly severe manner, and then you bolt that together to the frame, you could end up actually introducing a warp into the frame. So what this design does is, one third thing. If it was just one solid piece, that would essentially mean I have no adjustment for length, other than taking off the column and like chopping it in half and re-welding it. What this design does is it fixes all of that. Because it's in two pieces, here we go. I can better illustrate that here. Because it's in two pieces, what I was able to do is after I welded that, after my dad, I'm not a very good welder, after my dad welded these plates on, I bent it back into shape a little bit, and then I stuck it on the lathe and just turned this down this end so that it's as flat as possible, so that it's not going to warp the frame when it's bolted in place. And if we zoom in over here, we'll see a turnbuckle. So what this is going to do is this is going to allow the column to, each half of the column to rotate to correct for any misalignment. So there's flexibility in rotation. It's also going to be, because I have both left hand and right hand threads here. So if I loosen these nuts and turn this center turnbuckle while it's in place, or while it's bolted in place, that's going to slightly shorten or lengthen this center support column, which is going to allow me, for example, let's say the joints, when it's coming together, the joints are just a little bit too loose or a little bit too tight. This will allow me to put a little bit extra or a little bit less pressure on that. One of the easiest mistakes to make when you're designing something in the computer is not accounting for error, not accounting for tolerance. I mean, there's no such thing as perfect tolerances. So it's better to have a little bit of flexibility, and rather than relying on one solid piece being perfect. Well, keep in mind the jam nuts aren't so much for keeping it rigid. The jam nuts are to keep it from lengthening or shortening. Now, the one thing that I wish I had done a little bit differently is, so this is stainless pipe, and it's thinner than the aluminum I was planning on using, but it's still pretty hefty. It'll be fine for the prototype, but for Subcontrabassoon serial number 1 as opposed to serial number 0 over here, I'll probably end up trying to reduce the wall thickness for this piece of pipe here. Okay, well, I think that is everything I wanted to talk about. So, if anyone has any questions... Yes, yeah, Jared, there will always be some play in the threads. You are correct. But once again, so the purpose of this isn't to... The purpose isn't to so much hold... The purpose of the column isn't so much to hold it all together. It's to keep... I'm trying to phrase this the right way. It's to keep it from one frame from sliding down or up. It's kind of like sandwiching or lightly sandwiching the instrument together so that the body joints are able to hold the instrument together rather than relying on the column to hold the instrument together in its entirety. You're absolutely correct that it's possible that I might need to redo the turnbuckle a little bit, tweak it so that I might have to make a large. Right now, there's a nut that I haven't made yet that's going to solder in the inside of this for threads. Right now, I have it planned on being 25 millimeters long, essentially 1 inch. So it could be that I need to make that a little bit longer so there's more threads on the inside. But yeah, so that's what this is going to look like. And I was actually kind of impressed that this worked out because I would be lying if I said I had planned it this way. But there is just enough clearance on this screw here underneath. There we go. So, yeah. Alright, well, if there... Oh, Brendan says hi. Hi, Brendan. Muffin... How many girls will this instrument get me? I mean... If you came into classical music to attract... as a romantic... to attract romantic partners, I'm not sure that was the best reason to get involved in classical music. I don't think this changes any of that. And yeah, so Jared brought up the question of at least you won't have to play it on a stool like my contra clarinet. Yeah. I from the beginning I designed this with the same ergonomics as the contrabassoon in mind. So if you don't have to play on a tall stool to play contrabassoon, you shouldn't need to play subcontrabassoon. Now the downside of that is that means there's a lot of weight up above your hands, so you're probably going to need some sort of playing stand to take that. I don't know that I would go as far as Brett when he says converting everyone to being a bassoon player is the best way to control population growth, but I will say that being a bassoon is not the same as being a rock guitar player or whatever the modern cool version of that is. I don't know. I'm a little out of the loop in that regard. Okay. So my plans are my immediate plans, getting all of this stuff soldered together so that these frames are ready, finishing these nuts, the column, and the turnbuckle, and then I still haven't glued together the ABS body joints yet. So I want to do that, but in order to do that, I'm going to need to, so each vertical segment has 9 pieces, and I've given myself a little bit of extra length on all of them so that I can sand them down to be exactly as tall as they need to be. Because they're going to need to be pretty close. So that's going to take a little bit longer than when I'm sanding the crumhorn segments or something. Because it has to be perfectly, or not perfect, but pretty darn close to the same length, all 4 of those big vertical segments. Um, Brendan. So Brendan asks, instead of calling it a subcontrabassoon, can't you call it the bobaphone? Brendan, unfortunately, you've opened up a rant for me. So I still am a little annoyed at Heckle for calling their improved version of the bass oboe a Hecklephone and kind of forever causing causing a division in the low oboe world. If I were building a generic instrument designed to just be a 32-foot woodwind, then calling it the bobaphone might make perfect sense. Since I'm just building a giant contrabassoon, something that's supposed to be part of the bassoon family, I think it makes sense to call it something bassoon. I know Chip Owen at Fox was willing to express open annoyance at me for not calling it the octo contrabassoon, which is what he thought it should be called. But yeah, that's my reasoning for calling it a subcontrabassoon instead of a bobaphone. And Brendan, I know you were joking, but sometimes a joke leads to a rant. Okay. Well, I haven't gotten any new questions in a while. So once again, I'm gonna try to get some work done this next week. I don't have a rehearsal again until Sunday. And hopefully I'll see you all soon with some more progress. How else would Heckle maintain... so Sans the Skeletons asks, how else would Heckle maintain exclusive manufacturing rights to their wide-bore bass oboe? So... I should have a disclaimer that goes up in bright letters here that I am not a patent attorney. My understanding is that a acoustic fact is not patentable. The fact that you can make a oboe or a low oboe with a certain bore taper, I do not believe that that's patentable. Just like I don't believe it's possible to patent the idea of a contrabassoon that's an octave lower. I think what Heckle does have is the exclusive rights to the name Hecklephone. No one else... There are other manufacturers that have made large bore bass oboes, but they can't call them Hecklephones. Or even if they could, I don't think they'd want to, because then you're doing free advertising for another company. So, yeah. Okay, so Jared says that Yamaha patented the acoustics behind the Vinova. You know, if you're a company like Yamaha, if there's... I guess I should probably make a distinction between, when I say patentable, do I mean it's possible to get it patented, or you should be able to patent it? So, I would argue that... I don't know. A branched tube cylindrical bored instrument might be innovative enough to warrant a patent. I don't know, but just a cone of a wider taper, I don't think that would be innovative enough to warrant a patent. Anyway, I'm sorry, Antonio. I don't speak Italian. see what Google Translate thinks about subcontrafagotto. Okay. So Antonio asked, where did I come up with the idea of building a subcontrabassoon? It was actually based off of a misunderstanding. For a long time, there's been this idea that a Czech instrument manufacturer named Červený made a subcontrabassoon in the late 1800s, and that it wasn't successful and failed, and no one has really tried since then. And they did make an instrument called the subcontrabassoon, but it was essentially a reed what we would now call a reed contrabass that only went down to the low A of the contrabassoon's low A. But the idea of a subcontrabassoon kind of took over and kind of became a myth. So my instrument is a realization of that myth, which is why I decided on calling it subcontrabassoon instead of something else, because it's taking that mistake that textbooks have been repeating for 100 years and turning it into reality. Okay, well, if that's it, thank you all so much for coming. Like I said, hopefully I'll see you all again soon with some more progress. I hope everyone has a wonderful day.